Elon Musk presented Tesla's new battery that destroys entire industry. Tesla has introduced a new battery. Tesla is a company that never fails to surprise its customers and followers. Elon Musk, the brains behind Tesla, is re-entering the automotive business with a brand new LFP battery, which is far less expensive than current lithium-ion batteries. In today's video, we'll go over all there is to know about the all-new Tesla battery, including how it outperforms any other battery now on the market. So, are you interested to know more about this? Keep an eye on the video. Welcome to Elon Musk Future. Don't forget to subscribe to our channel and press the bell icon to never miss an update about Elon Musk. NMCA is an acronym for the common ingredients found in most EV batteries, particularly in legacy vehicles and our long-range electric vehicles. Nickel, cobalt, manganese, and/or aluminum are most commonly used. We already know that Tesla has developed a chemical that permits them to make a nickel-only cathode, despite the fact that nickel is rather abundant. It's because we require so many batteries that the only option is to use bonded components. This is what people think frequently when discussing lithium, and for example, how limited it is. Elon seems to be reassuring about how much lithium there is in the globe, while others are concerned that although this may be true, it can take several years for mines to start producing reasonable yields. There are, however, batteries that employ sodium instead of lithium, which is a more prevailing element. EV sales are still low, accounting for a small percentage of total sales compared to other cars. However, if they are to become as large as we all hope, they will need to rely on elements in high abundance. The issue is attempting to get as much efficiency as possible from them. The LFP battery will be the subject of a lot of research and development. It will be a crucial component of new energy. The fact that it is abundant is merely one of the advantages that makes it significant, as is the fact that iron is consequently less expensive. However, it has other benefits, such as being a safer and more durable battery, which is a crucial battery characteristic, and when the patent expires, it will be available for the rest of the globe. Trying to develop numerous types of LFP batteries for diverse purposes would be like the gold rush through free market innovations on a global scale. As we all know, the lower the barrier to entry, the fewer regulations there are and the faster the product evolves. Patent expirations represent a huge elimination of a barrier to entry after technology can progress. Elon, we argue that anyone who wants to use any of the 4680 patents also opened up all of their other battery-related patents. This will be in keeping with the mission objectives. As a result, Tesla may profit equally from the advancements of others in the field of battery technology. Given that EVs will continue to increase rapidly, they are still very early in the development of LFP batteries. In general, the backlog will continue to rise while the number of electric vehicles produced will increase dramatically. Not to mention the number of batteries it would require to power our devices. Consider how early we are in all of this and how much further the industry would progress. Over 10 years, the world may have consumed 1 or 2 times more batteries to make these transitions work. We'll need a lot of batteries. It's also natural that the ideal components to investigate with batteries are those that are plentiful. Of course, we will ultimately have recycling and will be able to reduce mining for all of these commodities dramatically. But that may be a few decades away. Tesla appears to be still rushing to produce as many batteries as possible. As a result, Elon has stated that about 80% of our batteries will be LFP. However, on the result call, Elon mentioned that manganese may be used as a cathode as well on Twitter. He also responded to the limiting factors, questioning about what Elon had mentioned on the call concerning a manganese cathode. It's an alternative to iron phosphate. According to Elon Musk, manganese cathodes appear to have a good chance of being a good option for various applications. Manganese could be a huge game changer if it can provide higher energy density than iron, as well as being low cost and abundant. This is major news. We just learned that Tesla is investigating a whole new EV battery chemistry, and it has the potential to be fantastic in a variety of applications. We may be able to look forward to a second battery day later this year. Hopefully, Tesla will demonstrate its LFP battery, which Elon has stated would not be the 4680. It's also possible that some economies of scale will be lost, but it's possible that Tesla will have twice as many batteries at its disposal. So, it will be worth it in the end. All energy batteries will be LFP. CATL will be able to keep ramping up those batteries for Tesla, and Tesla will most likely begin to profit from energy. But in terms of any new Tesla batteries, we'd say there's a good likelihood they'll all be cylindrical, just because that's the quickest method to make batteries. When batteries become more plentiful, Tesla will be able to pick up those and choose which ones to use. Beggars can be choosers right now, because there isn't much to choose from. At the very least, it is possible to generate more consistency in the battery packs. And they'll all be structural, because Elon Musk has stated that all automobiles should be built this way. And he's not one to look back. Could it be that in a few years, when Tesla has a more reliable supply of batteries, and Farish is better suited to the specific public, is it possible that the chemistry breakout will be like this? Their 6804 Nikola battery has a range of over 400 miles and is capable of great range and performance. Then there's the middle range, which would be manganese batteries with a range of 3 to 400 miles. This is a fantastic collection, and it's likely at a fair pricing point at this point. Then there's the LFP standard range, which might go as far as 200 miles by this point. Thanks to all of the new worldwide innovations we expect to see over the next 5 years. China is allowing Tesla to do business in their country, but they're going to impose significant tariffs on their battery industry, where Tesla will continue to order all FCA TLS batteries, but may not be able to produce their own. However, this agreement benefits Tesla, because it allows them to produce more cars and learn a lot about production. However, the Chinese CTL model, Y standard, would never have the same profit margin as if Berlin or Austin 4680 model. Why? For one thing, they may be created cheaper, and for another, they can be sold for a higher price. Yes, Tesla is the sole owner of Tesla in China, but it's probable that Tesla China will always be a Chinese battery. But that's fine. CETL can keep supplying Tesla to Asia. Tesla, on the other hand, puts its resources to better use elsewhere. The Asian sales are almost all extra sales that Tesla would not have gotten away with if it weren't for CTL. So, it doesn't matter if the profit mark is in SI. And as we previously stated, consider how much Tesla has learned from Chinese manufacturing. We have only seen the model while lines have grown. Anyways, the Alamo manganese batteries may arrive before Tesla's LFP battery. Elon stated that manganese, rather than nickel, may be used to replace the iron in LFP batteries, assuming that the chemistry is comparable to that firing, and the steady advantages are the same. Manganese, on the other hand, is supposed to have a higher energy density than nickel. This is why it's so significant. So if Tesla has made a breakthrough with manganese, it may have found the sweet spot for many electric vehicles. As a result, nickel is safe for vehicles that require a lot of power and richness. We already know that Tesla's FSD is revolutionary and fascinating, but so is battery technology. And Elon hinted that manganese batteries could be next. The LFP battery will have a ferrite size depending on which size is best for that chemistry, and its intended function, whether it's to save money or generate more energy density. The same can be said with manganese spattered. There will also be a new battery size for energy storage, which will be LFP for even power walls, because it makes so much more sense. As a result, the cost of power barriers should eventually be cut in half. However, they may become nearly twice as heavy. As a result, there should be 2 separate LFP sizes, one for energy storage and the other for electric vehicles. It is built around the most crucial aspects of the applications. It's evident that there will be a different standard range in China that is dedicated to using CTS LFP batteries. Therefore, these other batteries will likely only be used in Europe and North America. For example, Australia may be in Shanghai's catchment area. We will also deduce from this that Tesla is still working on its battery chemistry. They're currently experimenting with different chemistries to see what will work. Many of the lessons learned and techniques created may most likely be applied to a new battery line. This could be a game changer. Anyways guys, if you want to see more interesting Elon Musk videos, click the video right above. That's all for today. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.